So in this video, I'm going to work through some SAT math geometry problems that you'll see over and over again on Bluebook SAT practice tests and the real tests. I'm going to cover things like area, volume, surface area with triangles, squares, cover a lot of information about triangles, finding the side length to triangles, being able to use similar triangles, covering right triangles, even a little bit of circles in there, and also degrees involving lines, parallel lines, that type of thing. Just these are some of the problems that you'll see over and over again on the exam, or problems very similar to them. They're from practice test 5 on the Bluebook SAT practice tests. So just as a warning for spoilers, everybody. But anyway, yeah, I'm gonna work through these 6 problems, and hopefully by watching me, you can learn exactly what you should be on the watch for as you're preparing for your exams, what exactly to practice, what facts to memorize in order to do better on SAT day. So with that said, let's go ahead and dive into Bluebook and those geometry problems. And the first quick tip, using the reference sheet. So the first thing I want to go through is this reference sheet up here that gives you some handy dandy geometry formulas. You can see the formula for how to find the area, which is the inside of the circle, and the circumference, which is the length of the outside of the circle. The area of a rectangle, the area of a triangle, right? Radius, r is radius, pi is 3.14. Base is down here, and the height is this distance. And then the length of the sides of a right triangle, A, B, and C. Then the length and the angles of some other right triangles. The volume of a rectangular prism. The volume of a cylinder. The volume of a sphere. The volume of a right cone. And the volume of a right pyramid. It also gives you some things to remember. Is the number of degrees in a circle is 360. The number of radians in a circle is 2 pi. So 2 pi equals 360. And the sum of the measures in degrees of the angles of a triangle is 180. And one other thing I want to say is because the area or the number of degrees in a circle is 360, the number of degrees in a line, just a flat straight line, is going to be 180. That's an important thing to remember when doing geometry problems as well. So we can go and close our reference sheet and move on to solving some additional problems. Okay, so here's our first problem from some problems that you're going to see, or at least similar problems you'll see on SAT day. You may not see one that uses the exact same type of problem with just different numbers, but you'll generally see these, but with different variations. So just FYI, these problems are all from SAT Bluebook practice test number 5. So, spoiler alert. Okay, let's go ahead and read the problem now. The length of each edge of a box is 29 inches. Each side of the box is in the shape of a square. So you've got a box. The length of each edge of a box is 29 inches. Each side of the box is the shape of a square. So maybe instead of following the box like I drew, it's going to be more like that, right? 29, 29, 29, all the way around. The box does not have a lid. So you've got a side here, got a side here, but no side there. What is the exterior surface area in inches of the square box without a lid? So important thing to remember when you're looking at reference sheet is that this is not volume. This is surface area. How do you find the surface area of a rectangular prism? You're going to take the area of each of the outside shapes. In this case, these are squares, and you are going to add them together. So when you have a cube or when you have a other rectangular prism, then you're going to have 6 shapes, but this doesn't have a lid, so you're only going to have 5. How do you find the area of each side? Well, you actually do have this on your reference sheet. Area equals length times width. And because length and width happen to be the same in this case, that's just going to be for every single one of these sides, 29 times 29. Because you have 5 sides, it's going to be that times 5. So if you pull out your handy dandy calculator, you'll see that the answer is 4,205. So that's going to be the surface area of the box without a lid. The reason that you might see this problem come up on the test is because sometimes they ask you questions about surface area. You might need to know the surface area of a cylinder, for example. And so it's important you know how to calculate volume versus area versus surface area. Next problem. So here we have a problem that's quite common, has to do with triangles. Let's go ahead and read the question down below. It says in the figure shown, AB equals square root of 34, AC equals 3, and CE equals 21. So if you add those together, then they're equal to 24. What is the area and square units of triangle ADE? So how do you calculate the area of a triangle? Area equals 1/2 base times height, as we have in our reference sheet. And triangle ADE is going to be the entire triangle we have here, not one of the smaller triangles. And so that means we're going to have to take half of the base of the triangle and multiply it by the height. And typically that would mean half of AD. However, when you have right triangles, you can also take AE times DE and multiply them together and then divide by 2, because you can find the area of a rectangle and just divide it by 2, since the area of a triangle or a right triangle is half the area of that same rectangle. Right, so we already have the length of AE, it's 24. And in this case, we're going to have to consider that triangle ABC is similar to triangle ADE. So if you're to draw them out, you've got 30 square root of 34, you've got 3, and then you've got some other number over here, and then you've got this larger one, that's 24 down here. And because they're similar triangles, you know they have the exact same angles each there. You know that each side is going to correlate somehow. So because there's side 3 right here, multiply times 8 equals 24. So you can take that same side over here, square root of 34, multiply it times 8, right? Then you have 8 square root of 34, which is going to be the length of the hypotenuse of this other triangle. Right, and once you have that, you can use this handy dandy formula over here, which is also seen on your reference sheet, to calculate this DE. So C is always going to be your hypotenuse, and you can use similar triangles as we've already been doing, but you don't actually have to in this case because you already have 2 pieces of information. So C is going to be, whoops, I just realized that I had a mistake over there. This is supposed to be equal sign. C is going to be 8 times the square root of 34. So 8 times the square root of 34 squared equals 24 squared. We'll call that your A. It could also be your B. It doesn't matter. Plus B squared. And then you solve for B using that. So this is when you pull out your calculator and multiply this out. So it looks like B is going to be 40. But you can't stop there. You're looking to find the area of this triangle. So this is going to be 40 over here. So you just take some simple multiplication. 40 times 24 divided by 2. 40 times 24 divided by 2 is 480. So the area is going to be equal to 480. That's going to be your final answer. Okay, so let's move on to the next problem. Right here, we also have another problem that we see very frequently with lines asking us to correlate one angle with parallel lines and perpendicular lines and intersecting lines to another. Some important things to remember, as I've already mentioned, is the number of degrees in a line is 180, which means in this instance, the angle here and the angle here are going to be equal to 180. So, considering that, we can look at this graph and see that angle 145 and the angle next to it must be 35 degrees, since 35 degrees plus 145 degrees equals 180, which then means that x must be 145 degrees, because again, these two must be equal to 180, and this angle over here is going to be equal to 35 degrees. It just continues roundabout. That ensures that the number of angles on each side of line K on the line N are going to be equal to 180 degrees. So anyway, let's go ahead and read the problem and the answers and make sure that we know how to solve. In the figure, line M is parallel to N, just basically means line M and N never intersect. And K intersects both lines. Which of the following statements is true? The value of x is less than 145. Well, actually, we know that x must be equal to 145 because it's opposite of 145 over here, and 35 plus x has to equal 180, so x equals 145. That means that this one cannot be right. The value of x is greater than 145, as I just said. It's actually equal. Value of x is equal. That's going to be your answer because it matches what I just said. D says the value of x cannot be determined. As I already mentioned, it can be determined. So that's going to be how you solve that problem. It's pretty easy. You just have to make sure that you know those line tricks, that a line equals 180 degrees, and the angles that are in each side of the line must add up to be 180 degrees. So here's our next problem. A right triangle has legs with length of 11 centimeters and 9 centimeters. So right triangle, 11 and 9. What is the length of this triangle's hypotenuse in centimeters? This again goes back to our formula over here. It's very, very simple. Just know how to apply it. Hypotenuse is C. So if you have 9 squared, right side squared, then that's going to equal 202. And that means that since 202 equals c squared, in order to find the actual value of c over here, you're going to have to take the square root of that in order to get c by itself. So that means that c equals the square root of 202, which if you look at the problem up here, you can see is answer B. Next problem. A right rectangular prism has a height of 9 inches. The length of the prism's base is x inches. So let's go ahead and draw this again, like we did earlier. Drawing always helps. So height is 9, length is x, and the length of the prism's base is x inches, which is 7 more inches than the width of the prism's base. So we know, therefore, that the width of the prism's base is going to have to be x minus 7, since we know that the width is 7 more inches. So 7 more would take us back to x. So that means that if you were finding the volume, if you look at our reference sheet, it's going to be length, width times height. It says which function of V gives the volume of the prism inches in terms of the length of the base. So the length is x, or we're going to be able to solve so that every variable in this equation is going to be L, or in this case x, because x equals L. Luckily we already set it up that way, so the volume is going to be the length, which is x, times the width, which is x minus 7, times the height, which we already have as 9. Let's see if we can, there's the answer for that in the problem. Oh, right here, d, 9x, x minus 7. So that will be our answer. Final problem. In the xy plane, a circle has center C with coordinates h, k. Point A, B lie on the circle. Point A has coordinates h plus 1. So that means that you're going to have somewhere further out here. We'll call that point A, which is h plus 1, k plus the square root of 102. And ACB is a right angle. So that means you're going to have something approximately like that. What is the length of AB? So you're wondering what that is. So we're going to have to use some math in order to figure that out. You know that the x coordinate here at the center of the circle as h. So, and the x coordinate is h plus 1 over here. So the distance to get over to this point must be 1. So we'll call that 1 right there. And then same thing to get up here, the distance must be 102. Using our formula from earlier, a squared plus b squared plus c squared, we can find the length between right there where I've just bolded. So you're going to have the square root of 102 squared, which is just 102, plus 1 squared, which is just 1. So that means that your c, whoops, I wrote that equation wrong again. That means your value of c squared is going to be 103. So that means the square root of 103 is going to be your c right there. And so that gives you one length of this triangle that you're trying to build. Let's put that over there. And you also know when you're building a triangle, therefore, that the length of the other side is going to be 103 because both sides are radii, right? And the radius of a circle is always the same the whole way around, no matter where you want it. So both sides of the triangle have to be the same length. Therefore, you can also use this formula once again to find the hypotenuse of that triangle at AB. You're going to have 103 squared, which is 103, plus 103 squared, which is 103. And you're going to take the square root of that, so that's 206, because c squared equals 206. Square root of that is going to be so like that right there. I don't think you can simplify that, so that's what you plug in is your answer to that problem. Hopefully that makes sense. The key things to remember here are that a squared plus b squared equals c squared is a pretty important concept, that the radius is always the same no matter where you are in the circle, and that it's important to use tricks when you're trying to figure out, like, what does h plus 1 and k plus square root of 1 and 2 actually mean? Well, what are your x coordinates? What are your y coordinates? Think of it in terms of x and y, realizing that h plus 1 is just going to be 1 over to the right, and k plus the 102 is just going to be 1 square root of 102 added. Thank you so much for watching this video, and you made it all the way to the end. I hope you enjoyed this video. I have a lot of other great videos on SAT math, SAT reading and writing, other things that are more PSAT, or just other things like college applications, tons of stuff. So make sure you subscribe and help me in my own college application journey as I'm applying to colleges this fall. Again, I hope you really enjoyed this video, and I hope it helps you to be able to improve your SAT math score and get those SAT geometry problems right. So thank you so much for watching, and I'll see you again soon.